Now what if you have two arrays? So the examples that we just saw, that you have NP arrays, and then you have just a scalar, one value, and then you did some operation. So and then that operation with that one scalar is performed in all the elements in the NP array, the ND array, n-dimensional array. All the dimensions everywhere, that operation will be performed. But instead of a scalar, what if it is another array? Okay, so we have array 1, ARR1, which is 1, 2, 3, 4, 5, 6. And then we have another array, ARR2, okay, and that is 7, 8, 9, 10, 11, 12. And they both are exactly the same shape. They both have two-dimensional array, and the shape is 2 and 3. So shape of AR1 and shape of AR2, they're exactly the same, right? So if I do shape ARR1 and comma shape ARR2, I have to NP shape. Okay. So this is the first one is 2 by 3, second one is 2 by 3. They both exactly the same shape. Now if you do the operation, then what NumPy will do is it will pair up the elements, corresponding elements. Okay, 0, 0 coordinate in the first one with 0, 0 coordinate in the second one. 0, 1 with 0, 1, 0, 2, 0, 2. 1, 0, 1, 0, 1, 1, 1, 1. So it will pair up the exact corresponding location, and then whatever operation that you are trying to perform, it will perform that operation. So the 1 and 1, okay, so let's print the 2 so you can see it. Print ARR1. Okay, so that's ARR1, this is ARR2. Okay, so here are the shapes, they are exactly same. So when you add, so it's going to add the first one with first one, 1 plus 7, right? Where is that? I have that one up here. So I really need to move these two up. Okay. Let me move the shape up here. Okay. So when you add, you get 1 plus 7, 8, 2 plus 8, 10, 3 plus 9, 12, and so on. So they are matched up, and then the operation takes place. Okay. So same here, if you do multiplication of two arrays, then it's going to match up and do the multiplication. And if you do division, same thing. Okay, you match up and do the division. Okay, and if you want to raise one to the power of the other, again, all those operations, okay, will be matched up. Okay, so you have, first we saw scalar operation, where you have an array and just a scalar, one number. And if that is the case, then whatever operation you want with that one number is repeated for all the elements in the array. Now if you have two arrays, and if they are of the same dimension, then the numbers are paired. Okay. So any questions so far? Okay. Now, what if the arrays are of different shape? Okay. Now, if the arrays are of different shape, there are three rules that are followed. These are called rules of broadcasting. So when you have two arrays and of different shape, okay, so one is going to be of a smaller shape than the other, right? That's why they are of different shapes. So the smaller array is expanded out so that it will become the same shape as the first one or the other one, or the bigger one. Okay. And the way in which you expand out the array which is of smaller shape, okay, that's what these rules of broadcasting is about. You broadcast, you expand it, so that you will have the same size, same shape, and then you can match up. Okay. Now, you may not be able to do this broadcasting every time. So if the broadcasting is not possible, then you'll get an error. Okay. So those are the three rules. So the third rule is, of course, if it is not, if you do not agree, then you're going to get an error. So rule 1 and 2, if you are able to successfully apply rule 1 and 2, and you do get an exact same shape, then the operation will be performed. And at the end of rule 2, if you don't have exact shape, an error will occur. Okay. So what are the rules? Okay. If dimensions are not same, okay, add a dimension to the array with fewer dimension on the left side, on the leading left side. Okay. So here, broadcasting example 1, we have two arrays, M, that is of shape, two dimensions, shape is 2, 3, that is M. Now A is just one dimension, and there are 3 elements in that dimension. So this is M, this is A. Okay. Obviously, they are not of the same shape, so you cannot perform the operation of you want to add or subtract or do whatever you want. You can't do it, so you have to apply the broadcasting rule. So the first rule says, okay, so of the two arrays, the one with smaller number of dimensions, okay, so if dimensions are not the same, so the dimension here is 2, dimension here is 1, they're not the same, then add a dimension to the array with fewer dimensions on the leading edge. So this one has fewer dimension, so add another dimension here in front of the 3. Okay. All right. Now, same dimension, so now we have the same dimension, right? So this one is 2 dimensions, this one also has 2 dimensions. The same dimension, but the shapes do not match. Of course, see here, 2, 3, and then you add a dimension to the left, there is nothing there, so you're going to have a dimension here with all empty, blank, 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 right? So if that is the case, so the shape here is, then same dimension but shape do not match. If one of the shapes is 1, then stretch it to match the other shape. If neither shape is 1, go to, well, so here, so what's going to happen now is this is going to be 1, 3 now, right? When you add a dimension, A is going to be 1, 3. Both are same dimension, but the shape is 1. So now you expand it to 2 then. Increase it to match that one. So you have 2, 3 and 2, 3. And how do you expand? You expand by copying. You copy that. So 6, 7, 8 will get copied. So when you apply rule 1, so there you have only one dimension. So now you add a new dimension to the left. So now M is 2, 3, A is 1, 3. Now you expand, so since this is 1 and this is 2 here for M, you increase it. So you get 6, 7, 8, 6, 7, 8. So now you can perform the operation. So no error. So if you do m plus a, well, I don't, let me do it here. Okay, I have to run this first, I guess. Okay, then m plus a will work. It's no problem. Because broadcasting works, it's done.